The first Suzuki-type cross-coupling reaction between phenylboronic acid and haloarenes was published by Akira Suzuki and Norio-Miyaura in 1981. Suzuki won the Nobel Prize for Chemistry in 2010. The Suzuki reaction involves the formation of carbon-carbon bonds by the cross-coupling of an aryl, alkyl, or vinyl boronic acid, borate ester or borate with an aryl or vinyl halide, or triplet using a variety of palladium catalysts. The reaction is extremely tolerant to various functional groups such as carboxylic acid, ester, alcohols, aldehydes, and ketones, which makes it popular in natural product synthesis. The reaction is widely used to synthesize polyolefins, styrenes, and substituted biphenyls. In order to form diphenyl, or this aryl-aryl bond or carbon-carbon bond, we require aryl halide, boronic acid or aryl boronic acid in the presence of palladium catalyst and a base. So how do you synthesize boronic acid? We start with aryl halide, add butyl lithium to it, forming this organolithium. Then we use boronic ester to make aryl boronic ester. Then HCl, which will deprotonate this and form boronic acid. So let's look at the mechanism. We start with palladium acetate. This has the oxidation state of 2. So we're going to go from palladium 2 to palladium 0. So the first step is going to be reduction. Since this is palladium 0, now the second step is going to be oxidative addition. So it's going to go from palladium 0 to palladium 2, where this aryl bromide, carbon bromide bond is going to break and it's going to form this complex. So this bromine is going to coordinate with palladium in this manner, and the aryl is going to come here. Now the third step is just going to be ligand exchange. So this OR is going to exchange itself with this bromine. And M stands for the metal, sodium or potassium. OR, so R stands for either hydrogen, methyl, or ethyl. So it's going to be sodium hydroxide, methoxide, or ethoxide, a base. Now the ligand exchange. So that bromine is now replaced with OR. Now the fourth step is transmetallation. So this is the key point for Suzuki coupling. We start with boronic acid or aryl boronic acid, use this base, which we used here, and now it's gonna insert that ligand. So OR is gonna be inserted, forming this borane complex. Now for ligand exchange and transmetallation, so this aryl group is gonna exchange with OR group. So that OR group is gonna attach with borane. So you're gonna get that ligand exchange. So that's transmetallation. Now the fifth step is cis transisomerization. Since those two aryl groups are like this, one of them has to come here and that triphenylphosphine is gonna rotate and come here. So now the reductive elimination can happen. So these two aryl groups are gonna form that carbon-carbon bond. And now you have this diphenyl. After that, you're just left with palladium and 2 triphenylphosphine on it, which makes it palladium 0. So the cycle continues.